Hello everyone, welcome. So far we have looked at the basic probability, and after that we looked at the random variables, and we looked at few of the usual random variable. Now moving forward, we are going to look at operations on random variable. So basically these operations gives you some kind of summary of a random variable. Like in this lecture we are going to look at the expected value or the mean or the expectation of a random variable. So all these terms are the same. So this expected value is a single number that provides some kind of summary of a random variable by telling us what it is on the average. If you have not got this point, you do not have to worry. As we go on, you will have some kind of sense about the expected value of a random variable and what kind of summary it provides to you. You will have the sense of this also in this lecture. Okay, so what we can do, we can take an example and we can try to have some kind of picture of this expected value. What actually this expected value is giving us. Let's suppose today you are supposed to play a game, and let's call this game as a game of chance, right, where you are going to make some gains, right? And let's say you have the knowledge about few knowledge about this game. So what's the game? Let's keep it abstract and let's say directly that you are playing a game, right? And you will play this game maybe 100 times. So you have thought to play for long run, maybe you will play it for 1000 times today. So each time that you play, you win an amount of money, which is a random variable x, right? And the random variable can take the value 1 with the probability 2 divided by 10. So basically you are playing a game and you will make the gain of rupees 1, and that has the probability 2 divided by 10. And you will gain rupees 2 with a probability 5 divided by 10, and you will gain a rupees 4 with a probability 3 divided by 10. So each time you play, you win an amount of money which is a random variable x, and the random variable x takes the value 1 with the probability 2 divided by 10, or random variable takes the value 2 which is gain with the probability 5 divided by 10, and the random variable takes the value 4 which is again with the probability 3 divided by 10. So you are supposed to play this game 1000 times and you have this knowledge, right? You have this info with you. So if I ask you with this info that if you play it for 1000 times, how much do you expect to have at the end of the day, right? So how we can answer this question, that how much gain we can expect to have at the end of day without playing this game for 1000 times with this given info, right? So if we look at these probabilities as the frequency, what it tells you that if you play it for 10 times, then you will get 2 times with the gain 1. If you play it for 10 times, you will get 5 times with the gain 2. And if you play it for 10 times, you will get 3 times 4 gain, right? So overall point is that it is saying that you have the 20% chance that you will gain rupees 1, you have the 15% chance that you will get rupees 2, and you have the 30% chance that you will get rupees 4, or you will have the gain of rupees 4. So if we interpret these probabilities as the frequency, then what we can say, if we play this game for 1000 times, then what we are having the interpretation that we will have the gain of 1 rupees approximately how many times? 20%. So for the 1000, if we are playing for 1000 trials, then we will have 200 times of 1 rupees game gain, right? And 2 rupees gain for 50%, right? That means 500 times we will gain 2 rupees, and 4 rupees we will have gained the 300 times, right? So what would be our average gain? Our average gain, that will be, so what we have done, we are gaining rupees 1 for 200 times, we are gaining rupees 2 for 500 times, and we are gaining rupees 4 for 300 times, and we have played 1000 times. So this is what, how we find the average gain. And if you can look at this, we can also write like this. So 1 into 2 divided by 10 plus 2 into 5 divided by 10 plus 4 into 3 divided by 10, right? Let me first of all calculate this, what this will give you. So that will be 10 plus 12, that is 22, plus 2, that is 24 divided by 10, so 2.4. So what is this 2.4? This 2.4 means that if you play it for 1000 times, on each play you will gain a rupees 2.4. So if you play it for 1000 times, how much gain you can expect? That is 240 rupees, right? So what we have done, so we have calculated a certain quantity which is a sort of average of a random variable. So if you look at this summation here, so what we did in this summation, we took each one of the possible random variable and then multiplies with their probabilities, and we have sum up, right? So this is what the expected value. So how we can define the expected value of this random variable x is sum over this random variable times the probability of this particular random variable. Okay, so there are a lot of other points to talk about here, but I think you have got the sense of what is what if I am asking about finding the expectation value, what I am asking. So I am asking that what's the average value of the random variable is, right? So if you look at this question, we have given this info, right? And we ask that if we play this game for 1000 times, what is the expected amount or expected gain you can make if you play this game for 1000 times, right? So we have made use of this info, and we have concluded that the average gain is 2.4. So you can say the expected value is 2.4. What does it mean? It means that if you play this game for 1000 times, on each play or on each trial you will get 2.4, you will have a gain of 2.4 rupees. Although if you see that random variable is not taking this 2.4 value, but you should have the clear understanding about the average thing. Average is something that represents some kind of summary of a group of data, right? So this 2.4 is telling that if you play this game for 1000 times, then you will make 2.4 a gain of 2.4 rupees each time whenever you will play on each trial, right? So if you play this for 1000 times, then you can expect that you will win the 240 rupees, or you will have a gain of 240 rupees, right? So you have done this calculation. The point to note that you have done this calculation without playing the game, right? If you have played the game and if you have calculated this thing, then you are calculating the exact thing, right? We have some probability model. Now we ask the expected value to just to get know about the you can say the future, that with this info how much how much I can expect, right? So you have not done the trial for 1000 times, right? So I think for up to this you should have the sense of or the expected value, that what it is giving you and what is it what it is telling you. Okay, now you must be confused with this average value and the expected value, right? So let me make a clear picture about this average value and the expected value thing. Let's say uh, that you are rolling a die and the random variable has been exactly mapped into whatever the face occurring at the roll of die. So random variable can take the value 1, 2, 3, 4, 5, 6, right? And let's say the die is paired, so each will have the probability of 1 divided by 6, 1 divided by 6, 1 divided by 6, 1 divided by 6, and 1 divided by 6 with the probability. Let me write it clearly. Okay, I think it should be clear up to here that how we have defined the random variable, and random variable is taking may take these values with these probability, right? Okay, now let's suppose we roll a die for 2 times. So we are rolling a die for 2 times. So in this case the outcome, so let me write this one also. So first we are rolling a die for only 2 times, so all these are equally probable. So maybe we will get on the first roll we will get true, or on the second roll we will get 4, right? So this could be a chance, right? And if you try to find the average value here, what will be the average value of this outcome? The average value will be 2 plus 4 divided by 2, that is 6 divided by 2. Again you roll the die for one more time. Let's say on the first roll you have already got 2, and second roll you have got 4, and you roll the die for third times and you got, maybe you will get again 4 or 3, anything could be possible. So let's say you got this value 3. What's the average value here? So the average value is 2, average value of the outcome 2 plus 4 plus 3 divided by 3, that is 9 divided by 3. So again you roll the die for the fourth time. So maybe you have rolled the die for the first time, you have got the 2, 4, and the third time you have got the 3, and again you are rolling the die for the fourth time. So maybe you will get this 1. So what will be the average value here of the outcomes? That will be 4. That will be 4 plus 2 is 6 plus 3 9, 10 divided by 4. Again you will roll the die for fifth time. So maybe first you have got 2, 4, 3 and 1. Again maybe you will roll the die, again you got the 4, right? So what will be the average value of the outcome? So 14 divided by 5. So what's the point to observe here? The point to observe here is that this average value is not fixed. Now what I am saying, that you keep doing these trials, and let's say you have reached at the point where you are rolling this die for 1000 times, and after rolling the die for 1000 times, now if I ask you that what will be the average value of this outcome, now again you roll the die for 1001 times, right? Again, if I ask you that what will be the average value, so if you try to picture these scenarios, what is the observation here? The observation here is that so you have done the trial for 2 times here, you have done the trial for 3 times here, you have done the trials for 4 times here, you have done the trials for 5 times here. So when the number of experiment or the number of trials is less, these average values are fluctuation, these average value have much fluctuation, higher, not higher, but you can say the you can calculate the values are fluctuating too much, right? So once you reach at this point where you are rolling the die for 1000 times, and or maybe you are rolling a die for 999 times, then the average value, whatever the average value you will get here, or whatever the average value you will get here, or whatever the average value will get here, the fluctuation between these values will not be too much. So the point here to note is that this average value is getting saturated to some fixed value. So you keep carrying on this experiment, you do the experiment for 1 lakh times. So you roll the die for 1 lakh times, right? So you will observe that the average value will saturate. So you will start observing even at when you will do the experiment for 500 or trial for 500, 501, or up to 1000, 1001 times. So you will, if you plot, you will see that these average value will get saturated to some value. And where this value is getting saturated, these value where these average values are getting saturated is nothing but the expected value. So how you can see that this average value is getting saturated to the expected value, or in other words you can say these expected value of a random variable is nothing but the average in large number of independent repetition of the experiment. So these expected value is nothing but the average of a random variable in a large number of independent repetition of the experiment. So if you are rolling a die, or let's say if we roll the die for 1000 times, so we have these possible outcomes 1 2 3 4 5 6, and all these possible outcomes are equiprobable, right? And if you are rolling it for 1000 times, then we may say that each and every outcome has occurred. Definitely it will occur, because if we say that all are equiprobable, then, and if you are rolling it for 1000 times, so the number of trials are too large, right? Then definitely all these outcomes will occur, right? Not for the one time, two times, they will occur because all these are equiprobable, right? And if we increase the number of trials, then at the end you will observe that the occurrence of each outcome will tend to like equality, right? So what I am saying, that if you are rolling this die for 1,000 times, then and each outcome has the probability of that are equiprobable. So if we interpret these probability as the frequency, then what we can say, if we are rolling it for the 1,000 times, then maybe one we will get how many times, 166 times, let's say, and we will get outcome as a 2, again 166 times, because what we are assuming, what we have assumed, that we have the fair die and each die is the equiprobable, right? And let's say we are getting the 3 166 times, and 4 166 times, and 5 166 times, and you can also say that let's say we are getting the 6 maybe for 170 times, right? So what we have done, we have rolled the die for 1,000 times, right? And what we are expecting is that 1 we will get 166 times, 2 we will get 166 times, and 3 we will get 166 times, 4 we will get 160 times, 166 times, 5 we will get 166 times, and 6 we will get maybe 170 times out of these 100 trials, right? And how many times we have done this trial? 1,000 times. Total number of trials are 1,000 times. So if you observe this thing, we can write like this also, like that will be 1 into 0.166 plus 2 into 0.166 plus 3 into 0.166 plus 4 into 0.166 plus 5 into 0.166 plus 6 into 0.166, approximately it will be there. So the point here is, so you see, what is this? This is nothing but the average value for large number of trials, right? And this is nothing but this is same as, you see that this is nothing but the expected value. So what is expected value? Expected value of a random variable is a average value of a random variable where we do the large number of independent repetition of the experiment, right? I hope you should have now the clear picture about the expected value. So the interpretation of the expected value is that it is nothing but the average value in large number of independent repetition of the experiment, right? If you see, these are the value that the random variable can take, and and these are the probabilities, that is 1 divided by 6, and what we are doing, we are finding this the expected value. And if you look at the formula, this is what we have, the definition of this expectation, right? Now we can proceed. So I think you have the idea about what is this expectation value. Now we can proceed and we can look at few of the useful random variable and their expectation, or the expected or the mean values. So we will do in the next lecture. Thank you.